Video is going to the solution Lagure polynomial of first order. This is our next video on this series. So if you have not watched the previous video, do watch it. After watching it, come here. So we have seen that Lagure polynomial is denoted by Ly Px. It is denoted by summation r tends to 0 to infinity 1 by n 1 by, let's say, r n factorial upon n minus r factorial whole square. This is our into xn. Okay, this is our Lagure polynomial. Which is being called the Lagure polynomial of first order. So let it denoted by Px. Let's find some polynomial of first order, second order Lagure polynomial. Find a general result of a polynomial and we'll try to find it. Okay, let's say Px. We have Lx equal to this. So we have to find a P1. So what we get? Minus 1 to the power 1 upon. Here n is 1. So we'll come later in this. So we have an Cn, okay, C naught. In some of cases, what we see in some cases, some author put the C naught equal to n factorial. So this will be reduced as summation r tends to 0 to infinity 1 minus r n factorial, the power whole square n minus r factorial whole square, which is give our result. So we have seen this is our solution of another Lagure polynomial. Now we are going to see that what is the function that the polynomial is generated, or we are going to see the generating function of a Lagure polynomial. So let's write down the generating function of a Lagure. Generating function of Lagure xt by 1 by t upon 1 minus t equal to Lagure polynomial x t to the power n, which is n tends to 0 to infinity. So this is our Lagure polynomial. Okay. So if this is function equal to this, from this we can find a general equation of Lagure polynomial. So let's prove it. So we know that proof Ex equal to what? Xn upon n factorial. So apply this. So here 1 minus t, that will give us here x summation r tends to 0 to infinity minus xt upon 1 minus t. This is our x n by, let's say, r factorial. You can easily see that 1 minus et equal to, here minus 1 I take common, 1 by n. Okay, summation, I am outed from this, summation x to the power n t to the power n upon 1 minus t and r factorial. Since it is using r, so we are using r factorial. Okay, so since it is r, it will come into r. So when 1 by r x to the power r 1 minus t minus r plus 1 by r factorial into summation r tends to 0 to infinity. From this we get, look at this, we have seen this is our result. Okay, now that will give us summation r tends to 0 to infinity 1 minus r upon r factorial into xr. Okay, here 1 minus t minus r plus 1. Okay, since here if you use the binomial theorem in this case, okay, what we get, since here is minus minus plus, so which will reduce as r tends to 0 to infinity 1 minus r upon r factorial and x to the power r, let's say r plus s, which is after reducing this will give us the general form. We are using that since we know that what if a plus b equal to n, then we can write it c naught a n b 0 plus c1 a n minus 1 b. From that we similarly c and b and a. Similarly we get this after this, when we expand this, we should reduce as the term that x factorial upon s factorial. Okay, so this is the next version. So now it is time, summation r tends to 0 to infinity 1 minus r upon r factorial or factorial. Here we have r factorial, so r factorial into s. Since after that it will come here r plus s, it will give the double term, because here what we have, when you write it, it gives us 1 minus t r into 1 minus t. So this time is here r factorial for this, and s is because when we expanded 1 minus r, this give us this term s plus s factorial in denominator. Okay, s factorial upon r plus s, here r factorial whole square, so which give us the general expression for Lagure polynomial. So after the manipulation we get this result. This is give us summation r tends to s, summation r 1 minus r plus s factorial upon r factorial whole square into s factorial. Okay, since we have is that if we fix the r, let's fix r and very s. If r is fixed, let's say r plus s equal to n, so r give us n minus s. Put this value, will get r factorial equal to summation infinity 1 by r n minus s factorial, and here will give us n minus n factorial upon s factorial into x n. The alternative form of Lagure polynomial. Okay, so the solution and the differential of this equation give us Lagure polynomial. So Lagure polynomial is given by dy dx and upon n x to the power n e to the power n e to the power minus x upon dx n factorial. This is nothing but this is our Rodriguez formula. Okay, since from this we can find the Lagure polynomial, we see the Lagure Rodriguez formula in another place. So let's find it. So when we differentiate it, so expand this, okay? When we expand this by using, let expand by using what? By using Leibniz theorem. We get what? Ex n factorial is constant. So here, let's say u b. So x differential of minus ex. So first term differentiation. That is the polynomial of that is the same cases of polynomial theorem. So minus e to the power x differential of n term of x plus here we have written it, so it will give this is the differential 0. Zero means here is 0 means the differential not 1 plus x to the power. Now here it is the differentiation of one time. Now it will be c1 here c0 ex n minus 1. Let write n minus 1 as a differential of this. Similarly, we get cn minus 1 x to the power n minus 1 into e minus x plus cn x n e minus x, which is reduced as ex upon n factorial summation. Let's say instead of n I am using r 0 to infinity cn x to the power. Let's say here I am using the differential now, okay? So let's say this is dx n minus r d n minus r x n d n u. So this is our, so I am using it. So which is the form, that is the nothing but we have seen the in a binomial theorem that class 11 that if a plus b is written as what summation r tends to 0 to infinity, let's say a to the power n minus r b, okay, n, so b r, so which is our formula. So similarly applying this we get summation r tends to 0 to infinity x to the power n minus r differential, here I am using the differential, minus b we have e minus x r factorial, and we expand it, okay. That what is this? We know from d n xn is given by m factorial minus n minus n factorial m minus n. Similarly, dn by e x is nothing but 1 minus n e x, okay. So we are using this instead of this and this. Now it will give us what? Summation r 0 to infinity, and here will give us m factorial upon m minus n factorial x n minus r. This is r-term differentiation, so it will give us minus 1 plus r e to the power x. Here we have e x upon n factorial. This x will be cancelled and this will reduce as, so reduce as summation r tends to 0 to infinity m factorial minus m minus n factorial x to the power m minus n into 1 minus r. So from this we have seen this whole. So let's the sum Lagure polynomial. So polynomial of order 1, 2, 3, So we have seen that Lagure polynomial is given by d by xn n to the power ex upon n factorial. Okay, we have to find xn upon e minus x. So this is our so let's find L1 x equal to 0. Let's find the 0 order. First is if it is 0, so it gives no, so 0 will should not equal to 0. So let's find 1. So ex upon 1 factorial d by dx upon x minus ex. So which give us ex upon 1 factorial is 1. So e minus x plus x minus ex. So which will give us, taking ex is common, ex common, and e minus x 1 plus x. So it is give the 1. So 1 plus x. So this is our polynomial, Lagure polynomial of first order. We remember this 1 plus x. So let's find the second order. L2 is what? L2 is given by ex upon 2 factorial is d by dx square x to the power n square e x. So write down it. I'm going to next part. So which give us L2 is what? Ex upon 2 factorial and d by dx by d, we can write it d by d x square e x. So which is give us ex upon 2 factorial dx by dx. When we find it ex minus ex, we have to find a differential ex upon x square. Now this is our, now let's find the ex by 2 factorial. When we find it this term, it give us 2 into 1 plus x, 1 minute, be careful, 2 into e minus x minus ex plus x. Similarly here plus x square plus minus will give us minus, so 2x ex. So let's take ex is common. Obviously we will get ex, when since here power of ex is minus, so it will cancel and it give us 1 plus x by 2 factorial, since it is out of the bracket. So 2 minus 2x plus x square minus 2x. Okay, 2x will be added, it will give us 4x. Okay, so which is our, so we get x square by 2 factorial minus 2x by plus 1. So this is our second order polynomial. I think you have got it. So we remember the result of this. So have you done this? It is the basic differential equation differentiation. So let's find the second third order. Let's Lagure polynomial is given by ex upon 3 factorial d by x cube x square x cube e minus x. So this is our third order. So what we have to do? D cube ex upon 3 factorial d by dx, we can write it d by dx into d by dx upon x cube minus ex. So we have to differentiate it 3 times. Be careful. So which give us ex upon 3 factorial and d by dx. So when we differentiate it, it give us by using the shortcut method. Okay, write down the ex. I am using the shortcut method. Ex x cube. Okay, minus here minus, it will be alternate ex x cube. Here minus, it will give us plus e minus x 3x square. Since plus, it will be minus 3e. This is the second differentiation. Three 6 ex square. Since it is minus, it will give us plus. So I am giving a, let's, you have not understand. Okay, so let's take an ex is common. So ex common. So we have taken here the x to the power is 3. So we have to differentiate it 3 times and change the sign here minus. So we have to change the sign so that it will give our result. So x cube minus x cube. Since it is minus plus 3x square. Now we have differentiated. Now it is the time differentiate this term. So here minus this will be plus minus 6x. Since it is minus, now it is differentiated to this term plus 6. Now this is our first result. So similarly, ex upon 3 factorial. We have to differentiate this. Now separate this as a first term. Ex d by dx x cube minus ex d by dx 3x square minus ex 6x plus 6ex. Now this result will be exact of this. This result we have to find it. From in this way you can find it ex upon 3 factorial. So this result is nothing but ex. Connect. Be careful. Now sign will be changed. Since it is minus, obviously it will give us ex cube. This will be the positive sign. This is minus. This is plus 3x square plus 6x plus plus minus plus 6. Now it is time to this. So it will give us minus ex 3x square. Okay. Taking 3 is outside. Obviously 3 is outside. I have taken it. Now it is 6 minus. It will give us plus 2x. Now it is time minus 2. See, similarly it will give us here minus, obviously it will be plus ex upon 6 taken is outside 6 plus, since it is minus it will give us minus plus since 6 minus ex. So this is our result. Now find the next term. Find this after that you get ex upon 3 factorial. Ex upon 3 factorial. Now we have to differentiate this term. This term will be same. Now we have to, now be careful. Since ex is separated, this is under the bracket. So this is result exactly what we have done. Now we have the result this, and we can put the value of this from here, and after that we get a result which is 6 minus 18x square. 18x minus plus 9x square x cube, which is our result. Okay. Now for this n equal to 0 you can find it. When you find it, Lagure polynomial is given. Check. I think you got it. What is the theory behind this? Must until the, and thank you for watching the until the end. 0 is 1, Lagure polynomial 1 is 1 plus x. Lagure polynomial 2 is what? Lagure polynomial 2 is, I have forgotten. 2 minus 4x plus x square. Lagure polynomial 3 is given by what? 6 minus 18x minus 9x square minus x cube. Okay. This is Lagure polynomial t. Find the Lagure polynomial x. So this is the sum result. We have to be careful, and so do like, share, subscribe.